guys, today we'll be doing LeetCode number 2095, delete middle node from a linked list. This is a medium question on LeetCode. Let's get to what the question wants us to do first. So I'll consider example 2, 1, 2, 3, and 4. What we have to do is like essentially just remove the middle of the linked list and make it such that the previous one points to the middle's next. Now there's two ways to figure out the middle, right? Two ways that I can think of, but one being length. So we could calculate the length of the linked list. We could have a pointer traverse the linked list, and then we could like just do a floor division on 2, right? And we would have our length at the end. So if we consider 1 2 3 4 7 1 2 6, that gives us a length of 7 by 2. We would get 3, and that is the node that we want to remove, which points to 7, right? And then you could do another pass where you figure out the previous node, and then you make that node equal to the one in the middle dot next. But there's another way, the one that I actually want to talk about, slow and fast pointers. And the trick with slow and fast pointers is the fast one moves at a certain rate faster than the slow one, and this can be 2 times, 3 times, 4 times, whatever amount you want it to be. In this case, we would like for it to be 2 times, okay? Because if the fast, let's say, takes n steps to go to the end, then the slow would be sitting at n by 2 if fast is 2 times of slow, right? That's how we would do it. So slow would be sitting precisely at the node that we want to remove. And another way to make it even more easier is to have a previous pointer that stores slow's previous node, so that at the end all we have to do is just do previous dot next is equal to slow dot next, and that would perform the rewire. So I'll start writing out the code now. If you do slow equals to head, slow and fast both are at head, and if you do previous as null right now, we move fast 2 times quicker than slow. So dot next, right? And previous is the current slow, and the new slow has moved 1 ahead. At the end, all we have to do is, like I said, previous dot next is equals to slow dot next. Return head, because we've changed that. We don't need to create a new node or anything, just return the head. And now why does this work? So we'll consider 1 2 3 4 again, because it's the most simple one. Fast and slow both sit here at the start, right? Fast moves 2 times of slow, so slow is here while fast is here in the first iteration, right? And then we'll consider, I'll write it out cleanly. Then we'll see, okay, fast will go up until here, it will go to the end of the list, sorry, and S will then promote itself to F, and this will be previous, to be precise. So if we have PSF that way, then as you can see, S sits at the node that we want to remove, and this line over here helps us. So P dot next is actually 3, right? And we want to make that equal to slow's next, which is 4. So we essentially removed 3 and made a new line like this. And there's another small edge case in this. There is this as the linked list. So the way to avoid it is just to do if not head.next, return an empty list, because when you have this, we do slow and fast, right? And the while loop doesn't run, so because there is no fast.next, so the while loop doesn't run, and previous is null, so we are doing like none.next, which is invalid, right? That's why we would just have this test case at the start, and that code right here should work well. So yep, that's it. Slow and fast pointers and simplifying it